I'm sure that I'm not alone when I say that every CPU launch in the last little bit, Zen 5 Intel, has been traumatic. Expectations did not align with reality. It was a bit of a horror show, and that's a thing. I mean, Zen 5. Let's talk about Zen 5 for a second. Zen 5 is legitimately groundbreaking. But when it launched, it was a little bit, the rocket was okay, but it might have blown up the launch pad, might have given mission control a little bit of a scare. I mean, Zen 5 in an EPYC server is a love letter to system administrators, but the desktop counterpart, Zen 5 desktop CPUs that launched a couple of months ago, that was a bit more rough. It was a lot more rough. The 9800X3D is launching now, though. That's what this video is about. 3D V-Cache, gaming CPU. It's going to have the same problems as the Zen 5 CPUs had on launch, right? Because it's based on Zen 5? Actually, no. Not even a little bit. The 9800X3D is unequivocally the best gaming CPU you can buy today. This reinforces the idea that the previous hiccups, the whole rocket launched but the launch pad is gone scenario, had more to do with Windows optimizations than with the product itself. Okay, maybe the hardware, the I/O die is a little anemic for Zen 5. Is it a hardware or software problem? So, yeah, it turns out it's definitely more software for what we're seeing here, or the 3D V-Cache is making up for whatever other hardware anemia that there might be. At least with our 9800X3D testing, that's what I'm seeing. One of the exciting developments here is the overclockability and the fundamentally different package assembly for 3D V-Cache this time around. AMD is experimenting with stacking order. This could be a hint at how they plan to stack chiplets in the future, too. Maybe, possibly. A portent of things to come, if you will. In the previous generation, 3D V-Cache was stacked on top of the CPU cores, which created a thermal challenge, a little bit of a thermal blanket. Now imagine if the 3D V-Cache is placed beneath the cores, and the I/O just goes through that. This means that the heat-generating cores are even closer to the integrated heat spreader to the top of the CPU, improving thermal efficiency, because they can get hot and then the heat can go up. And that means that now you can overclock the 9800X3D. And that's pretty exciting. But wait, what's the gaming bottom line? In my gaming test, I observed an average of 9.1% uplift compared to the 7800X3D. Yeah, there's two games where it was around 1% lower, meaning the 9800X3D was slower than 7800X3D, and we'll talk about those. We'll talk about specifics. But versus Intel, whether you want to compare to the 14900K or the Core Ultra 285K, it's not even a fair fight. I mean, the Intel CPUs are not even in the same zip code anymore when compared to the 9800X3D. If you threw out the games that didn't improve or regressed by less than 1%, we're now closer to 10% generational performance uplift, gen on gen, versus the 7800X3D, which is quite a gap, considering the amount of V-Cache hasn't changed from 7800X3D to 9800X3D. And for productivity tasks, removing the power constraints, that boosts multi-core performance by not 10, but closer to 20%. That is significant. It's a significant leap for content creators and professionals and anybody that wants a little bit of an oomph. To be clear, I'd still prefer a 12 to 16 core processor for productivity, but you can get it done with the 8 cores here. Oh, and don't worry, if you want a 65 watt eco mode machine, you can do that here too. The eco mode worked just fine on my CPU and mostly did not impact gaming performance. It really only impacted the multi-core productivity workloads, not the gaming workloads. Let's talk more about gaming. Let's see the performance. Let's see the graphs. We can start with the artificial benchmarks. I mean, the artificial benchmarks, they are what they are. I also really didn't want to test against the Core Ultra 9 285K because it is a 24-core, 8-core versus 24-core. And yet, an 8-core CPU is able to achieve a 10,000 score multi-core. That's the uplift I was talking about. But also, look at that 1220 single-thread score. It beats the single-thread score of 1121 in our 3D Mark CPU profile result. Very, very impressive. And the Time Spy and Firestrike results, well, hey, look at that. An 8-core CPU leading the way by a lot. Neat. Assassin's Creed Mirage, this is one of the ones where there's like a 1-ish% performance regression. The 9800X3D is very, very slightly slower, and yet the 99th percentile is a little bit better, and the 95th percentile is even better than that. So your actual gameplay experience is largely unchanged or slightly measurably better, even if you're maximum frame rate, or your average typical frame rate, is very slightly lower. It's more consistent. And this is significantly better than even the 24-core Core Ultra 9 285K, which costs significantly more. I am sure that there was temptation inside of AMD to price this thing at $600. But then where are you going to price the 12 and the 16-core processor? 480's right. And as we expected, higher resolutions like 4K doesn't really make much of a difference. I really also question, like, gameplay at 1440p for me is legitimately a lot more fun than gameplay at 1080p. And I really like seeing the performance improvements in 1440p as we go through the benchmarks. I'm not going to call that out every time. Just keep that in the back of your mind. It's like, yeah, how I would actually play this game also significantly improved. Now, if you have a 7800X3D, is it worth the upgrade? No. But if you have a 5800X3D, maybe. And if you have anything other than those and you play games, it's in a different zip code. Baldur's Gate 3 in the city, because Baldur's Gate 3 doesn't have a built-in benchmark. This was surprising to me. I was surprised that the performance is this much better in demanding scenarios in Baldur's Gate 3. Even at 1440p. Even at 4K a little bit. Now, a couple of these graphs also include the 7900 XTX, and that's because I want to talk about the 7900 XTX a little bit more on the Linux channel, but hey, the 7900 XTX, it's holding its own in performance here. Yeah, the 4090 is faster, but good lord, you could get two 7900 XTXs, and it's really darn fast. It also benefits from the 9800 X3D. Borderlands 3 is a positively ancient title at this point. Ancient titles generally run better with lots and lots of 3D V-cache. That might mean AMD should revisit, hey, do we need 2 stacks of 3D V-cache in the future? Maybe. Would that make sense for what comes after 9800 3D? Probably not. But maybe the generation after that. It just depends on what we get for AAA titles. F1 2023. Why 2023 instead of 2024? Just consistency with old benchmarks. This is another one, too, that was useful to call out more than a 1% difference between the 7800X3D and the 9800X3D. This may just be something different in Zen 5, not so much an optimization problem. Too many people jump immediately on the, oh, this is a scheduler or an optimization problem. Maybe. But sometimes it is just differences in the hardware from one generation to the next, and that is just a fact of life. Now, there may be a way that you can say, if you're on newer hardware, do this wildly, completely different thing, but that's going to be up to the game developers, and the game developers are not going to go back and revisit F1 2023, especially when you got to buy F1 2024, because next year, or 2025. Far Cry 6's in-game benchmark is a pretty significant uplift for frame times and overall. Again, this is improvements in Zen 5, the Zen 5 generation, as well as our average frame rate. Final Fantasy, Into the Forest on the high preset, you get a little bit of a performance bump there too, although it evens out. There's really not a lot of difference for 1440p or 4K, even on Team Blue. Now, Forspoken, that was one of the ones where Intel kind of pulled ahead in the performance in Forspoken. I mean, nobody's actually playing Forspoken, but Forspoken was interesting maybe from a benchmark standpoint. But yeah, the 9800X3D also pulls ahead. Horizon Forbidden West, the 9800X3D takes the lead, although at 1440p, it's basically a wash. There's a 1 FPS, this is within margin of error at 1440p and 4K. Red Dead Redemption 2, we'll talk a little bit more about in a sec, but Red Dead Redemption 2 doesn't really benefit from Zen 5, or it benefits a little bit from Vcache, but by the time you get to 1440p, not tremendously. Shadow of the Tomb Raider, it's ancient, but it's always useful as kind of a benchmark title, and I didn't think we would see something significantly faster than 390 FPS, but we do get 408. And we can even push beyond 408 when we talk about overclocking, which I will in just a second. 1440p, we also get a little bit of a performance benefit there. Again, that 95th percentile is the frame time consistency with the 9800X3D. Very impressive. And that's probably as much to do with Zen 5 as it is 3D Vcache, because Zen 5, in my opinion, based on what I know on the server side of things, is a better all-round core. It's much more well-balanced in terms of speeds and feeds and memory bandwidth, AVX512, which doesn't, it's not really a thing for gaming, but those kinds of improvements lend itself to, this is going to be a little bit more even, and that shows through in the frame times. Warhammer 40K Space Marine, it's a pretty good uplift over the 7800X3D, but again, if you have a 7800X3D, you're not throwing it out to get a 9800X3D. But if you were on the fence or you were building a gaming machine, now is the time. This is as good as it gets for quite a while. Starfield has a significant performance uplift for the way that we benchmark Starfield, so that's nice to see. Also included a little bit of the SVM testing. We'll talk a little bit about virtualization-based security on or off. I always toggle it on or off in the BIOS. With Windows 24 H2, that is much less of a performance hit than it has been in prior versions of Windows 11, but there's still room to improve. And there's also some game titles that need to look specifically at what they're doing in virtualization-based security scenarios, because if you as a game developer find that your game runs significantly better with virtualization-based security off, you need to look at what's going on in your game engine or in your code to figure out what you need to do to improve the situation, because something can definitely be improved. Virtualization-based security should have a 1 to 3% performance impact, and when it doesn't, we need to call it out, because that's the only way it's going to get fixed. There's also some experimentation here with to CUDIM or not to CUDIM. CUDIM is something that benefits Intel. There's not really any reason to use it right now anyway on AM5. Even if you got CUDIM, it's going to do a fallback mode where it's not really using the CU part of the DIM. It'll work, but it doesn't really convey any benefit. And there is non-CU DDR5 that'll run at 8,000, and I did test that on this platform as well. Really, that just closed the gaps when we're talking about something that was missed in cache anyway. So it can help frame times if you run at an absurdly high memory frame rate in some games, but generally it's not worth the cost. You'd be better off putting more of the dollars into the GPU and less of the dollars into the most expensive memory you can get. DDR5 6000 with good secondary timings is all you need for this platform, which is fantastic. Again, it's a gift to gamers. The unsung improvement of this generation, it's the 99th and 95th percentile. Frame times, consistency. The gameplay experience is smoother than ever. Even in titles that showed basically no performance improvement, things like Red Dead Redemption 2, the improved frame times on the 9800X3D do make a noticeable difference when you're doing actual real-world gameplay. I know RDR2 has a built-in benchmark, but real can benchmark versus gameplay, and it's harder to capture gameplay, especially when the variance is a few percent. I tested with both the NVIDIA RTX 4090 and AMD's Radeon 7900 XTX, which I have here with me on the table. It is, the 4090 is undeniably the fastest GPU on the market, but at $1,800, that's a hefty investment. Is it worth it? Personally, I don't think so. Ray tracing is cool, but it only has slightly more meaning than Ricardo Montalban explaining to me rich Corinthian leather. That's what I hear every time I hear RTX on. It's Ricardo Montalban telling me about the rich Corinthian leather. You should know the story behind that, though. The Radeon 7900 XTX is priced at under $1,000, and it's readily available, and it's it is clearly the best bang for your buck for the highest end gaming. It's usually real world close enough to an RTX 4090 for everything except ray tracing performance that, just get the 7900 XTX, because good lord, the performance, it's ridiculous. Now what about overclocked scenarios with the 9800X3D? Because that's a thing now. We can do that. Well, out of the box power defaults are reasonable for the CPU in my opinion, and it's okay, but significantly higher base clock than the 7800X3D, but only a 200 megahertz boost at 5.2 versus 5.0 of the 7800X3D. But I did spend a few hours with the Curve Shaper and managed to squeeze another 100 megahertz out for gaming workloads, which is non-trivial. I mean, that took me to over 430 FPS in Shadow of the Tomb Raider, and that gave me about a 15 frame per second boost in Cyberpunk 2077. Again, that's the canned benchmark, and the canned benchmark is very flawed. Real world gameplay is not necessarily representative of what you actually get in a Cyberpunk 2077 benchmark. I just want to say, again, you got to take the Cyberpunk results with a little bit of a grain of salt. I don't even know if I want to include them in the main part of the review, but yeah, it's one of those things. Cyberpunk is interesting on Linux because Linux gets some optimizations that have now made Cyberpunk generally perform better on Linux than Windows, which is interesting. And the 9800X 3D performance consistency is best in class. Let's talk about Windows benchmarking specifically and virtualization-based security. The bittersweet reality is that AMD is the uncontested gaming leader, and they have the best 8-core desktop CPU in nearly every metric. Raw performance, gaming performance, power consumption, you name it. But that was also true with the prior generation of Zen 4. That's why I say bittersweet. It was always trading blows with competitive products from competitors, but was Zen 4 also uncontested? Well, it turns out Zen 4 had the potential to be uncontested in gaming workloads, and it was the gaming champ over the 14900K, so what really held Zen 4 back? Windows. This issue isn't exclusive to AMD anymore now either. Intel is experiencing it too. The architectural philosophy of Intel's Core Ultra Series 2 is even more aligned with how things are on the AMD side of things than the monolithic nature of the 14900K. I mean, think about it. It took them from Zen 4 launch until almost Zen 5 launch, slightly after Zen 5 launch, really, to get Windows sorted out. 24H2 has helped Zen a lot, and simultaneous multi-threading remains a variable. I'd say 80% on game developers and 20% on Microsoft at this point. SMT does help AMD platforms a lot, but Intel doesn't do it anymore, and AMD is messing around with SMT in their software, which I think is taking confidence in SMT as a benefit to gamers away, when reality is that it's probably just something in Windows, because SMT on Linux is glorious. It's great. It doesn't hurt anything. Now, by this point, you may be screaming into the monitor, okay, cool, I'm sold in the 8-core part. Where's my 12 and the 16-core part? They are conspicuously absent. A good reason for that might be to get the software right in the context of our current conversation. No matter how you spin it, subpar software support is what led to a less than stellar launch for Zen 5, a part that is the leader in its performance class in server and productivity workloads. Now, CES is just around the corner. Maybe we'll learn more about those 12 and 16 core parts, and I certainly don't blame AMD if they're taking some extra time to make sure that the software is perfectly right. But that also means the software had better be perfectly right. But there's also good news. AMD's work to get the 16-core parts running well on Linux, the 7800X3D and the 7950X3D namely, it's a lower headache, and it's already really amazing. So the work's basically already been done on the Linux side of things. 3D Vcache plus non-3D Vcache. Whatever AMD wants to do with the next generation 16-core parts with Vcache is going to be pretty glorious already. Another thing we have to watch for is virtualization-based security. This can be on, and even when it's off, Windows has bugs where it'll say it's off, but it's actually on, or the Windows subsystem for Linux actually turns it on, or other reasons that you can have a hypervisor on, even if it doesn't look like you're using hypervisor-based security. Now, supposedly, that's supposed to be a 1 to 3% performance hit, but on the pre-Windows 24H2 updates, it was more like 10%, 15% or more. 1 to 3% is reasonable. It should be on. You should have it on for security. AMD tests with it on, and with it on, it actually works really well. But it's going to be up to us, apparently, gamers, to keep an eye on this and complain loudly when things are not right in the operating system. Fortunately, AMD has a new ally in the quest for processor optimizations in the operating system, and that's Intel fans, because Intel needs the same optimizations to benefit the Core Ultra. Hello and welcome, Intel fans. Let's get that operating system optimized, and or just screech loudly when things don't work as they should, because, you know, whatever. A lot of people are blanketing this under like scheduler issues, but it's not really just scheduler issues. You really just need software and hardware to work together architecturally. Sometimes it comes down to scheduling, but even the Linux kernel is not perfect. It's just that the Linux kernel gives you some more knobs and tunables to do some of those kinds of things in user process land, to leave it up to the user to be able to do it without having to have like system level or kernel level permissions to really get it done. And so it's choices in the operating system that make it a little easier or a little harder when we're talking about Linux versus Windows. And to be sure, Linux gaming performance on the absolute is a bit lower than Windows, but it's getting better all the time, and that's exciting. And you should check out the Level 1 Linux channel for some more info on the 9800X3D in those contexts, because I think you'll be pleasantly surprised. And finally, we got to talk about launch time pricing, right? Well, this is how we know that this is a love letter to gamers from AMD. The 9800X3D launches at around $479. We've got basically the best gaming CPU in the world for under $500. Paired with the 7900 XTX, this is an unstoppable gaming monster. And you don't need CU DIMMs, you don't need ridiculously expensive memory to get it done. To be clear, we did test CU DIMMs, and the Kingston Fury CU DIMMs so far seem to be working best on this platform. I tested on both the X870E Tai-Chi as well as our 870E Hero. The 870E motherboards may even be maximum overkill. I've got an A620 that this runs basically fine in, although the gaming performance in a couple scenarios is like 3% not as good, which is not how AM5 is supposed to work. But you can basically use a potato class A620 motherboard with a 7900 XTX, and if you don't need much else, it does get the job done. Exciting times launching at 480, but I can't wait for the 12 and 16 cores. I'm Wendell, this is Level 1. If you have any questions or I missed anything or we just want to chat, hang out in the Level 1 forums. I'm signing out, and I'll see you there.